Hey there, welcome back to Python programming series. In this series, we're diving into the world of synchronous programming. It's a fundamental concept in Python development that you're going to understand if you are serious about writing Python code efficiently. In synchronous programming, tasks are executed one after the other in a sequence. This means the program waits for each task to finish before moving on to the next one. It is like waiting in line at the grocery store. You can't check out until the person in front of you finishes. Here is an example how the synchronous programming code is execution. Let's jump into some code to see synchronous execution in action. Here is a basic Python script that's going to synchronously execute the code. So here we have a function synchronous task. This simply prints out numbers 1 through 5 iteratively. Uh, let's run it and see what's happening. Let's just print as the starting synchronous tasks in the beginning before printing the numbers through 1 up to 5. And then processing synchronous tasks just print us to 1 out of 5. And finally, it prints us synchronous task completed. So as you can see, the tasks are executed one after the other in sequence. So the program waits for each task, which means printing the processing synchronous task uh, with number 1 up to 5 to finish before moving into the next one. So the advantages and limitations of synchronous programming. Synchronous programming offers simplicity and predictability, which can be great for certain types of tasks. However, it's important to note that synchronous execution can lead to blocking, especially in situations where tasks take a long time to execute the program. When one task takes a while to complete, it can hold up the entire program, making it unresponsive. This is why understanding synchronous programming is crucial for writing efficient Python code. Here is real-world examples of synchronous programming. File conversion script converts files from one format to another, example, CSV to JSON. Reads data from a source file, performs necessary conversions, and writes the transformed data to a target file. So this is a synchronous approach, process files sequentially, ensuring each file is converted before moving on to the next one. So that's wrap up our introduction to synchronous programming in Python. I have covered the basics of how synchronous code executes sequentially, the advantages and limitations, and even looked at some real-world examples. Remember, understanding synchronous programming is essential for writing efficient Python code. So keep practicing, keep learning, and I'll see you in the next video. And I will explore asynchronous programming for improved performance. See you next time.